Hi, my name is Ellie Tidman, and my presentation is on the effects of the amount of time a leaf pack is in the water on leaf decomposition and macroinvertebrate colonization. I would like to begin by thanking my family who spent numerous hours helping me create my leaf packs and then went out into the Mattaponi, which was sometimes up to our belly buttons, to extract my leaf packs. I would also like to thank my marine environmental science teacher who helped me come up with a way to execute my project and helped me with running my stats. Lastly, I would like to thank all of you for coming to watch my presentation. So some background, leaves naturally accumulate into packs within a stream. This is what a natural leaf pack looks like. Artificial leaf packs are made as a way of introducing leaves to test the colonization of macroinvertebrates. And this is what an artificial leaf pack looks like. Macroinvertebrates are bugs with no backbone that can be seen with the naked eye and are commonly used to tell water quality. These are some examples of macroinvertebrates. One of them is a snail. One is a mayfly, one is a stonefly, one is a coleoptera, one is a scud, and I don't know what the other two are. And lastly, the breakdown of leaves is necessary for the health of macroinvertebrates. My independent variable was time. There is no specific time that a leaf pack should be left in the water, and this is why I did this project. I've seen many previous projects that involve leaf packs, and people have just chosen times that they feel is best to leave their leaf packs in the water. So I wanted to test whether these different time periods would have an effect on what was caught in the leaf packs. I chose to leave my leaf packs in for a minimum of 1 week and a maximum of 8 weeks. One of my dependent variables was leaf decomposition, and I looked at the leaf decomposition of each week, and I knew from previous studies and prior knowledge that leaf decomposition would increase over time, but I wanted to find the rate of decomposition that occurred in my leaf packs over the 8 weeks. My second dependent variable was macroinvertebrates. Each macroinvertebrate has a specific role in the stream. Predators are one example that eat other macroinvertebrates. Filter collectors are another type that sieve through and remove matter that's in suspension in the water and feed on fine organic material. Grazers are animals that graze or scrape material from organic substrates. And shredders are organisms that eat decomposing tissue or wood, plant tissue or wood. The diversity, abundance, and species of macroinvertebrates all help to show the health of a stream. For my methods, I began by making 48 leaf packs out of a synthetic mesh material, and I filled each of them with 235 grams of leaves. I then put them into 6 clumps in the Page Road stream in the Mattaponi River. This is a map of Virginia, and starred is where Caroline County is, which is where the Page Road stream is of the Mattaponi. This is a picture of where the Mattaponi meets Page Road, and then it's starred where I placed my leaf packs. This is the actual site on Page Road, and each X marks where a clump of 8 leaf packs was placed. I then pulled 5 leaf packs each week from one clump. One clump was lost within the first week because we originally placed 6 clumps, so we were going to pull 6 each week, but we ended with 5. The leaves were then sorted through, and the macroinvertebrates were counted and identified. After this, we then left the leaves out to dry for 24 hours, and then their dry mass was taken. My first hypothesis is for leaf decomposition. My null hypothesis states that leaf decomposition would not be affected over the 8 weeks, and my alternative hypothesis states that leaf decomposition at week 1 will be less than the leaf decomposition at week 8. My second set of hypotheses is for the amount of macroinvertebrates. My null hypothesis states that the number of macroinvertebrates at week 1, or time will have no effect of the number of macroinvertebrates, and my alternative hypothesis says the number of macroinvertebrates at week 1 will be less than the rest of the weeks. My third and final set of hypotheses is for macroinvertebrate diversity. My null hypothesis states that the diversity would not be affected by time, and my alternative hypothesis states that the diversity at week 1 will be less than the diversity at week 8. This is my first graph. It shows the leaf decomposition that occurred over the 8 weeks. There was an obvious linear relationship, which then led me to run a linear regression, and I received a p-value of 1.81 times 10 to the negative 8. Because this p-value was lower than 0.05, I was able to reject my null hypothesis that time had no effect on leaf decomposition. This next graph shows the relationship between time and the amount of macroinvertebrates. Because there was not a linear relationship between all the data, but the independent variable was continuous and the dependent variable was categorical, I ran a linear regression on data from weeks 1 to 4 to receive a p-value of 2.53 times 10 to the negative 13th, and then I ran another linear regression on weeks 4 through 8 to receive a p-value of 1.26 times 10 to the negative 7th, and because both of these p-values were lower than 0.05, I was able to reject my null hypothesis that time had no effect on the amount of macroinvertebrates. This graph is for Shannon diversity, which I need to fix, and see, that was messed up. I have a graph for richness I need to put in, I have a graph for Simpson I need to put in. So then, I'll move to the applications. I was able to tell the water quality of Page Road, and it was good, meaning that the stream was healthy. I was also able to say that the optimal catch was at 4 weeks for both the amount of macroinvertebrates and to get the most amount of feeding groups as well. And with that, I was then able to find the rate at which the leaves decomposed, and I could say that at 4 weeks, the leaves had decomposed 25.7%. So even if your temperatures were different, because I did my project in summer, so in winter it would take longer than 4 weeks, but the optimal catch would still be at where the leaves had decomposed 25.7%. And for future research, if this project were continued, I would use synthetic leaves that were the size of a leaf that had decomposed 25.7%. And this way, I would be able to look at the colonization of macroinvertebrates at a constant, where the leaves were a constant size. However, there may be very small catch because of there being no leaf decomposition, which means that there wouldn't be as much of a buildup of organic matter. The end. Thank you.